All right, so what we're going to do today is review a little bit about information from mean, median, mode, and outliers. And then we're going to talk about this data distribution notion, okay? So our objective today is to, one, we're going to review the effects of an outlier on the spread and center of a set of data. So we're going to do a little chart of that. And then the second thing would be to compare data distributions via dot plots. And I don't know if I told you guys this, but there's another name for dot plots. Did I tell you that yesterday? Okay, if you watched the video, you would have found out. Another name for dot plots is line plots. So where they came up with that one kind of cracks me up. I guess because you could draw a line connecting one stack to another, or it's on a line, yeah. There's a lot of stretch going on these definitions. Okay, so what we're going to do is look at each of our statistics, the main ones, mean, median, and range, and we're going to talk about what effect an outlier has. So first, we're going to talk about mean. And before we talk about the effect of it on the mean, my question is, what is the mean? How do you calculate a mean? What is it representing in the data? Brian?
It's basically the average.
Okay. It's also known as the average. Okay. That's another name, but that doesn't tell me what it means or how I get it. Bastian? Okay, so add all numbers in a set of data and divide by how many numbers were in the data. Okay. And so let's talk about how does an outlier affect. If you have an outlier, will your mean stay the same? No. And so we're going to use a generic term because we just discussed that sometimes that could increase the mean or it could decrease the mean depending on where that outlier is. So we're just going to say it changes the mean significantly. So there is some sort of change. The change can go up or the change can go down. Okay? All right, let's talk about median. All right, how do we get median? What is median? Explain that to me. Jason. Wow, that is a very particular situation. That they would perfectly balance each other out. It is possible, but I would say that's not probable. So it could happen, but it wouldn't be always what happens. So, in other words, mathematically, when you add an outlier, you are going to have your mean change. Okay, whether it's on both ends or whatnot. Okay?
The median's like the middle of the data.
Okay, I need a little bit more because there's something that's really specific about the median other than it being in the middle. Okay, Ian? Yeah, we need to put the numbers in order from least to greatest, and then we find it in the middle. So it's the value in the middle of a set of data that has been put in order from least to greatest. And probably a word that we would attach to median would be the word middle. Okay. So based on our experience in the Explore activity, what does the outlier do to the median?
Sometimes it changes.
Okay.
But not always.
Yeah, there could be a change. Is it going to be a major change? No, it's not probably going to be. It's going to shift it from one number to another or between two numbers, but it's not going to be a significant change. So we're going to say changes median very little. Oops. Or not at all. Okay. And I'm going to shift to the next screen. Everybody good? And let's look at range. Okay. Now, range could be regular range, or a range could be interquartile range. Okay. But what would be the description of what range is? Mac?
Subtract the smallest number from the highest number.
Okay, so I'm going to use the word that means the answer to a subtraction problem. What's that word? Oh, I heard somebody. Yeah, the difference. So it's the difference. So in math, that means subtraction answer. The difference between the greatest and least value in a set of data. And then we'll add in the interquartile range as part of this. And that would be the difference between the first quartile, Q1, and the third quartile, Q3. Okay. So, will the outlier have an effect on range? Yeah. Yeah, and it will have an effect, and most likely it will have some sort of significant change. So it changes the range / interquartile range significantly. Okay. All right, so let's talk about our third thing, or second big thing today, which is comparing the data distributions. So are we good? All right, so let's talk about data distribution. So data distribution is basically the layout of the data. And the really best way to look at it is looking at a dot plot or some other sort of graph, okay? So data distribution, the layout of data as seen in a dot plot or other visual display of data. So other, I would think, would be something like a bar graph, maybe even a histogram. We would be able to see the same sort of relationship. Okay, and again, we're going to be talking not so much about bar graphs, because you guys have talked about bar graphs for several years, but more about histograms, because histograms look like bar graphs, but they do have a significant difference. All right, so I'm going to give you 3 examples, and we're going to compare them and title them. Now, I'm not going to put numbers on the number line because that's not the important bit. The important bit is just visually looking at what you see. So if you could copy mine. Oops, I only want to go up to 3. Next one, I'll go up to 4. So there's the first one. Okay. So notice that all of these charts go to the same height, that their largest column has 4 marks in it, 4 symbols. We have some places where there's only 1 mark. There's some places where there's 2, some where there's 3, some where there's a blank. Okay. So each of these has a name. The first one is called skewed. And here comes the hard part, left. And what that's basically telling you is where's the outlier located. It looks like we've got some stuff that's out to the left. So if you think about it, it's outlier left. Now, I'm using that word outlier very loosely. We don't know mathematically if those are outliers or not, but if you keep that notion of things are out kind of to the left, that's skewed left. All right, what do you think the middle one is called? Ian?
Balance.
Okay, now, I like that word, that's really great. Apply it to a term that you've heard in math class. Okay, a word that you've heard that means balanced in math class. Okay, Chris? Okay, equal. Now, it doesn't always look like that to be what I'm going to talk about. Okay, Spencer?
Equivalent.
Not equivalent. Miles?
Bell curve.
Okay, yeah, but we're not talking about that. Oh my goodness. All right, let me ask you this. If I drew a line down here, what are we talking about, Molly? Symmetric. So this is called a symmetric distribution. Okay, because there's balance. So I'm going to put that word underneath there. Balance from the middle out. Okay, so we have a tall center and we have descending to the left, descending to the right. There's this balance that shows up. Now, it doesn't have to be perfect to be considered symmetric, okay? All right, so now, so far what we've labeled, what do you think we would call the last one? The last one. Brian?
Skewed right.
Yeah, he's called skewed right. And again, how I would kind of remember it is that there seems to be some values that are lying out towards the right. Now again, I'm using outlier as a very loose term here. Okay. All right, so what I'm going to do is we're going to do one example, and then we'll call it a day on this stuff. So let me, you guys good? Can I move? Yep. Luke, you okay? So I'm going to give you 2 graphs, and these are going to be dot plots that were made of 2 track teams and how many miles they ran in one day. Okay? So we've got Team A. And since they didn't always run whole numbers, they ran half miles, we're going to actually put some half miles in ours. So the smallest amount that they ran was 3. So I'm going to go to 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, and then 6.5. So I'm going to put in the 2.5, and then 3.5, and the 4.5, and the 5.5, and the 6.5. And this is what they came up with this particular team. 2 of them had run 3 miles. 3 of them had run 3.5 miles. We had 4 of them that had done 4 miles. And we had 4 of them that had done 4.5 miles. We had 3 who had done 5 miles. We had 2 that had done 5.5 miles. And then that was it. Okay, so that was Team A. Here's Team B. We're going to do the same number line with the same scale. So 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5. Label those up. I'm going to do the odd ones. It's always good to whatever is your first tick mark, you should have a number on it. Oops, that's supposed to be a 5.5. So this is how Team B measured up. So let's see, we had 1 person who went 3 miles. We had 2 people who had done 3.5 miles. We had 2 people that did 4 miles. We had 3 people that did 4.5. Bless you. We had 4 people who did 5 miles. We had 6 people who did 5.5. 1, 2, 3, 4, 5, 6. Whoa, that's a tall one. And then we had 5 people who did 6 miles. Okay. Now, what would you say about Team A? Look at their distribution. What would you see would be true about them? Tristan B.
Symmetrical.
Okay, so we call it a symmetric distribution. And what does that mean, to have a symmetric distribution? Ian?
So basically there's 2 or 1 that are at the most, and then it falls like down on either side equally.
Okay, so can we use some of our statistical terms that might help us out here? Brian?
The data is like pretty even
Compared to the, where's my statistical words? Okay. What are these guys evenly split around? Okay, what are they evenly split around? Okay, Miles? And not only the median, but the way that that symmetric distribution is laid out, they're also evenly distributed from the mean. Okay, the mean, since these numbers are identical, this one we're going to have an even distribution. Around the mean and the median. In fact, in this case, most likely the mean and median would be the same number because of the symmetric distribution. Okay? So let's look at these other guys. What kind of distribution does this other team have? Okay. Which this one? Lucas? Yeah. So this is a skewed to the left distribution. And what could you say about this team? Now again, remember we used some statistical terms when we were talking about Team A, that there's an even distribution around the mean and the median. What could we say about Team B? Bastion? Would there be even around the mean on B, Team B? If the data is skewed to the left? Josh?
No.
Okay, no what?
There wouldn't be
Okay, so what would we be saying? Based on, okay, let's be more specific. Okay. Here's where you guys need to go beyond spitting back data. This is where you now need to think about what you're looking at. I think you spent too long spitting back data from a teacher. Your job now is to start thinking. Where would the mean be, do you think, in Team B? Where do you think the mean would be, Johnny Ray?
Towards the right.
No, number-wise. Where would the mean be?
Towards like 4 or 5.5.
Ooh, 4?
I meant 5.
Okay. All right, that looks like that would be a reasonable spot, right? To be here. So look at how many people are in front of where the mean might be and how many people would be after where the mean would be if we think the mean's going to be somewhere around 5. Looks like we've got almost half of the team, more than half of the team being over the mean. That's kind of interesting looking, all right? And median-wise, we're going to have more people running higher numbers, okay? Running larger distances. So I would say more than half of the team ran distances greater than the mean. And we could prove that out by doing some calculations, okay? So again, will median and mean in a symmetrical distribution be approximately the same? Yes or no, for Team A? Median and mean, will they be about the same? Okay, and I would say I would agree to that. So mean would be approximately equal to the median because of the way the data is split up. Okay, will it be the mean and median be the same in a skewed data? Will they always be equal? Okay, and no, the answer is going to be mean is not going to be the same as the median. Now, depending on where the skewing is, your mean may be lower than your median, or your mean may be higher than your median. It just depends on the direction that's skewed. The direction this one is skewed, chances are, now we've got so many people in the high range, we still may be slightly more to the right, but the median might be less, okay? It just kind of depends on how it works. If it was the other direction, then we'd probably have a lower mean and a higher median. So it just kind of depends on that. So that's what you guys are going to work on tonight on the guided practice and the independent practice. Okay?